Yeah. So I'm going to solve to some LeetCode easy problem. So given an array integer nums and an integer target return indices of two numbers and such that they add up to target. Okay. Okay. You may assume that each input would have exactly one solution that you may not use the same element twice. Okay, fine. So integers and indices. Okay, index. Indices we have to find out. So 9. Target amount is 9. And we have suppose 2 rupees, 7 rupees, 11 rupees and 11 rupees. So we have to find out the indices of target 9 rupees. So okay. So first indices and second indices. 2 plus 7, 9. So first and second. So output is 0. Okay, fine. That is a very simple question. And 3, 2, 4. And target is 6. So indices is 2 and 4. 1. Okay. Second indices and third indices. So target amount is 6. And here, okay. That is simple only. So uh, we can solve this one uh, in many way. But okay. I'm going to write this code on efficient way because suppose if we'll use that brute force approach, so that time like what we call we'll pick one element like one element and we have to check all the remaining elements. So that time complexity will be high. So suppose like here like n number will be there, right? So with every number we have to check, with every number we have to check like 10 20 number it is there, so we have to check with every number like again and again we have to compare. So that's why time complexity will be high of n square. So that's why I'm not going to choose a brute force approach because I'm doing comparison. So like first loop and second loop, two loop I'll take. So first loop will be n and second loop will be n. So that time n of is correct. So that's why it is not good, like because that is a very slow for a large input value. So yeah, so I'm going to use here, yeah, using of quick sort algorithm also we can do, but in that also like you have to compare with every element. Okay, so I'm going to use hash map. Simply I'm going to use hash map. So idea is like instead of checking all pairs, I'll try to store number with those indexes value, and for every number I'll try to calculate those complement value, that is 9. So I'll try to do like that, like I'll check if complement already exist in our map, so that time I'll return those value. So yeah, like that, let's solve those questions. Yeah, so we have this is C++. In Java I'm going to solve. Yeah, so public into zone, nonce value we have and target value we have. So I'm going to write first as I told, like hash map I'll use. So in hash map I'll try to store all number with their indexes. Okay, so hash, okay, hash map integer and integer. So this is map, map and new hash map. Then I'll take one loop. In that, I'll through array I'll try to iterate those till the end. So for and I we have to find out those indices. So I'll start from 0. I less than nums of length, and I plus plus. Then what I'll do, like, okay, current indexes and which one is final one, those complement. So int current indices, here I'll store those nums of I value, which one I'll return directly, like first one, and I'll try to store like those complement value. Int comp complement value, here I'll store like those target value and current value. Okay, so target target minus cu curve. Then I'll check if a complement value is already there or not. So like that I'll do, like, let's see if map dot, I'll take those key. So contains of key, and which one is complement? Zero and complement. Then what I'll do, then if we contains value, it will take. Okay. Then then I'll return I'll return those indexes of this complement value. Okay, and those current value, whatever I'll get. So here I'll return I'll return new and return new and try to get from map those comp value. Yeah, so and those are indexes, those current indexes. Okay, so it will return. Then what I'll do, I'll close this. Okay, then what I'll do, I'll try to store current value with indexes. Okay, then I'll return all new value whatever I'll get from here. Okay, so I'll try to store those value. Map dot put current value and those indexes, and then I'll return new and and let's see. Yeah, so yeah, so for this, time complexity will be O of n, and space complexity will be O of n as well, because I'm using those hazmat. And like if we'll use brute force approach, so that time that is not scalable, because like suppose like some extra number will get, so like we have to compare with every remaining element for finding those target amount. So that's why that is not a suitable approach. So we use here hazmat. So yeah, that is faster as well and all those things. So now, yeah, now I'm going to solve threesome. So we have like we have a given array integer, like array nums, and we have to return all the triplets nums of I, j, and k, such that I is not equal to j, and I is also not equal to k, and j is not equal to k. Okay. Okay. So nums of I, yeah, so here we have to find out those unique triplet in the our array, like whose sum is 0. Okay. So like here, like we have to find out to 0 after adding all those values. So minus 1 0 1 2 3 4. Okay. Minus 1 minus 1 minus 2. Okay. So after adding all this value, will get 0. So this is like similar of to some coding question, like similar of to some coding question, but in to some we are finding not at like in to some we are finding those indices, but here we are finding those value, not indices. So target amount here, target amount is 0, but into some target amount 9 it is there. So minus 1 0 and 1. Okay. And here target amount in triplet way, that is not 0, so that's why here no output, empty, only possible triplet does not up to 0. Means only possible triplets it is there. So we'll go with efficient solution only, because if we'll go with what you call brute force approach, so that time also time complexity will be of n square, because I, j, k it is there, so we have to write 3 for loop, right? So that's why like time complexity will be like O of n cube. So that is not good, and sometimes we'll get TLE as well. Like suppose we have like n number of numbers, like suppose n equal to 5,000, 10,000. So that time we'll get like billions of operation. So that's why the brute force approach is not good. So we'll go with what we call efficient approach. We'll use sorting. Yeah. So what we'll do, we'll try to sort first this one. Okay. Then we'll use two pointer approach, like left and right. So if we'll use two pointer approach, so that time also time complexity will be high only, not O of n. But compared to brute force approach, here like we'll try to minimize the time complexity of O of n square. Okay. So I'll try to sort array first. Then I'll fix one element of those I value. Then I'll use like two pointer approach, like left right, and in left I'll try to add with one, and in right I'll try to subtract with minus one. Then I'll try to move those pointer. Let's see how it goes. Okay. Notice that solution set must not contain duplicate triplet. So yeah, yeah. So this one we have to take care. So we'll try to skip here duplicate as well. Okay. So we'll take one array in Java. I'm going to solve. Yeah. So we'll take one array, and here I'll try to store all the triplet value. List of list teacher So as I told, I'll sort first this array. So yeah, let's sort it. Array dot sort. I'll pass those nonce value. It will get sort value. Then I'll take one loop where I'll try to fix like element on that time as well. Okay. So for int I equal to 0, I is less than nums of length. What I'll do, those value minus 1 or 2. Okay, triplet we have to find out. So minus 2 I plus plus I plus plus. Let's see how it goes. Then I'll try to skip all the fixed element. Okay, so int int left equal to I plus 1. Okay, and int right equal to those n value nums of length minus 1. Okay, okay. I'll skip those duplicate value as well. Okay, so I'll give one condition. If I is greater than 0 and nums of I is equal to nums of I minus 1, then what I'll do, I'll try to do continue, try continue. Okay, then then like while left is less than right value. Okay, if less value is true, that time like restore you in sum equal to nums of I plus nums of left value plus nums of right value. Right value. Then give one condition. If sum is 0, I'll give condition if sum equal to 0, then what I'll do, I'll try to add all value which one will be there on our list. Okay, so in result try to add result I'll try to add arrays as list arrays dot as list dot nums of I value and left and right value, nums of I and nums of left and nums of left and nums of right. Okay. After that, what I'll do? Yeah. So it will store here and okay. I then again I'll try to what we call then again I'll try to skip those duplicate left value, and then again in another condition I'll try to skip like right duplicate value. Okay, so for that so while left left is less than right and nums of left is equal to nums of left plus 1. Okay, nums of left plus 1. Then here I'll do left plus plus left plus plus. Then in other condition I'll try to skip like I'll try to skip duplicate right value. Okay, so for that also we have to write. So while suppose left is less than right and nums of nums of right is equal to nums of right minus 1, because we have to so here right minus 1, because we are trying to remove the right duplicate value. Then 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 in else if condition what I'll do, I'll try to sum. If it is a too small, then I'll increase those value. Sum less than 0. I'll increase left value. Similarly, I have to do for right as well. Okay. Else right minus. If it is a too large, like yeah. Let's see. We have to return those value as well. I haven't returned. Okay, we have to move both pointer as well. So left plus plus right minus. Yeah. So yeah, fine. So here time complexity will be of n square and space complexity will be of n, because like we are excluding those output list. Okay, so that's why. Next, what I'll do, I'll solve for sum. Okay, fine. I'll try to solve this medium threesome closest problem first. Let's see how it goes. Okay, so given an integer array nums of length of n and integer target. Okay, find three integers at a distinct indices in nums. Okay, such that sum is closest to target. Return the sum of three integers. Input has exactly one solution. Okay. Okay. So minus 1 to 1, so target is 1 and output is 2. So that the sum that is closest to the target is 2, minus 1 plus 2, that is 2. Okay. So yeah, got it. So 0, triplet is 0. Yeah. So uh yeah. So like here like we have a like one integer array of nums, and as we have a target, like here like we have to find out target as well, but in two sum we are looking for indices, and three sum we are targeting those value, not indices, and three sum here we are targeting those value, like here like two sum. But thing is uh, like here triplet so yeah. Okay, threesome. Yeah, so we have to find out three integer. Okay, we have to find out three integer, and they're like which one it is a near of those target value, that on only we have to return those closest some kind of things. Okay, so suppose like we have like we have taken minus 1, 2 and 1, that is sum of 2, and another one we have taken minus 1, 2 and minus 4, that sum will be minus 3, right? And another example we have taken, suppose like minus 1, 1 and minus 4. For this output will be minus 4. And another example, suppose we have taken 2, uh, 1 and minus 4. Okay, and triplet we have to find out, right? So only four possible pair it is there, four possible triplet it is there. So one is 2, another one is 3, and third one minus 4, and another one minus 1. So which one is closest? 2, because that is the closest sum of target one value, right? So that's why 2 is the correct output. So yeah, let's move. Here also like threesome we solve like that also. Here like time complexity will be, if we'll use brute force approach, so time complexity will be of n cube. So here also we'll go with what we call uh, efficient approach only. So here I'll use like same as I used sorting and two pointer approach on threesome here. So here also I'll use same approach, sorting plus two pointer. Like I'll try to sort those value, this value, then I'll use two pointer approach. So because sorting will help like those all movement like for controlling, and two pointer will use for reducing as we'll use what we call three loops, because three integer we have to take, but we'll use two pointer approach. So I'll try to reduce three loop to two loops, so that time complexity will be of n square. So yeah, three closest sum. So I'll try to sort arrays dot sort those value, nums value, whatever I will get. Then what I'll do, try to store here all the closest and closest sum. Sum, try to nums of, try from 0 and nums of 1, nums of 2, 2. Then I'll use here two pointer approach. So I'll try to store in left value those I plus 1, and in right value I'll try to subtract with minus 1, because I'm going with end point and end indices, and from starting I'll go. So I plus 1 and right terms of length minus 1 is 2. Then yes, I'll take one loop for int I equal to 0. Is the nums of length minus 2 I plus plus. Then minus 1 2 1 minus 4 1. Okay. कैमरा आएगा भाई. बाहर चल रहा बाहर
नहीं लाइट है तो देखो ना दिखाओ ना देख लिए देख लिए
yeah. So sorry guys. Yeah, so like in left two pointer I'll approach here, I'll store, then I'll use those what we call file left is less than right, left is less than right. What I'll do, I'll try to I'll try to store those nums of I value and nums of left and right value in one place. Okay, so int current sum, int current sum nums of nums of I value plus nums of left value plus nums of right value, nums of left value, right value. Okay, fine. Then what I'll do, take those math dot abs. I'll try to update those closest sum. So I'll try to math dot abs current sum minus those target value. Okay, it's less than math dot abs closest closest sum minus target. Then I'll return here closest sum equal to current sum.
हेलो हाँ भाई क्या मतलब
Then
विकास
I'll
को
check if I'll check if current sum is less than target value, then I'll move those pointer and I'll increase those sum value. Okay, so if it is true, then left plus plus I'll increase those value from left indices. Okay, then in else what I'll do, I'll check current current sum current sum is greater than those target value. If it is greater than the current value, I'll decrease from right indices. Right, minus minus. Then 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 else I'll return current sum value. Then what I'll do? I'll return finally closest sum. Closest sum. Let's see. Yeah. So for this time complexity will be O of n square. So I'm going to solve another one more question. Okay. So I'll solve a four sum. This question also similar to what we call three sum and three sum closest. So here, yeah. So this question is also similar to three sum and three sum closest, I guess. Let's see. So given an array, nums of n integer, return an array of all unique quadruplet. Okay. A, B, C, D, such that. Okay. So A, B, C, and D are distinct. Okay, fine. Nums of okay. You return the also any order. Okay, fine. So here, this question is also similar to this question, threesome question. Okay, this question is also similar to here. Like we have to find out those zero for everything, but here like we have like here also, but here like quadruplet it is there, not a triplet. Okay, so here here also like I'll try to use sorting plus two pointer approach for optimization uh, optimized solution I'll try to implement. Like if we'll use those brute force approach, so that time uh for loop I have to use like for one so yeah, for loop I'll use, so that would be like over for like n to the power 4. So that's why that would be not great, right? So that's why like I'm going to use brute force approach, I'll use like sorting plus two pointer approach. Okay, so that time also like time complexity will be of nq, but it's compared to foursome. Sorry, it's compared to brute force approach, that time will not get TLE kind of things, because like if we'll use for nested for loop, so that time more chances will get TLE. Okay, so suppose like we have a 500, so that time like billions operation it will be so that's why I'm going to use efficient approach, like I'll use those sorting plus two pointer approach. So it will reduce our for loop for loop from two loop. So yeah, let's see. Okay, so we I have to return the answer in any order. Okay, fine. So here okay, fine. So for that what I'll do, try to store here all the stuff of result. I've taken one list here. See, then there is dot sort, like how we have sorted on what we call in threesome clauses. So that's why similarly here also I'm doing nums sorting will be complete. Then in value here I'll try to store those nums of length because every time I have to write. So nums of length, okay, and I'll return result as well. Here only return result as well. So this is fine. So minus 1 0 minus 2 3 minus 1 minus 2 2 minus 2 0 2 minus 1 0 0 1. Okay, so target है साइलेंट कर लो भाई और 15-20 मिनट.
Hello? Hello.
So so okay, for int I equal to 0, I is less than those nums of length those minus one loop for this, then I'll try to do minus one. Okay, okay, minus 3, then I plus plus. Let's see in another what I'll try to do in another for loop. Int j equal to I plus 1 j minus n minus 2. Okay, j plus plus j plus plus. Next what I'll do, okay, so here like I'll skip the duplicate value like for I value. So for that what I'll do, like if I is greater than 0 and nums of I is equal to nums of I minus 1, then I'll continue this and continue. Similarly I'll do for same thing for j as well. Here j is suppose like j is greater than I plus 1 and nums of j and j minus 1. Okay, so it will remove those duplicate value for j. So after that what I'll do, while left is less than right. Then I'll try to calculate using those loop. So int nums of I plus nums of j plus nums of left plus nums of right. I'll store here. Then I'll give condition sum if sum equal to target. Those are like if target value will found here, then we'll go inside. Then we'll try to add those quadrant value, all those value. So in result we'll add arrays dot as list. Result will add dot as list. Then we'll add all nums of I comma nums of j comma nums of left and nums of right. Then what I'll do, then I'll move this to left pointer if it is there. Then I'll move this to the left pointer if it is there. So left plus plus will try to increase from left to right. So yeah, and similarly will okay, yeah. Then skip if while left is less than right and nums of left if it is true, if it is true, nums of left, if it is a true, then I'll do left plus plus equal to left nums of left and so on. Then I'll skip this one as well. While left is less than right, left is less than right, and nums of right equal to nums of right plus 1. Right minus 1 is because we are coming from right to left. Then else if condition will do try to sum is less than target, sum is less than target, left plus plus Next, what I'll do, else minus will return the result. I'll check edge case as well. With this, it will not resolve. Let's see. Once. Okay. Long value. Let's see. Large number is there. Yeah. So that's it for today. Thank you.